which worksheet was this? The one with the, okay, what is this? 8A? Okay. 8A, we need to finish these examples. Do you want me to go over this first one, or are you okay with the first one they did for you? I don't care. I can go over it if you want. I didn't do this one yesterday, right? It's already done on your paper, so just watch me for fun, okay? It says 3x squared, so that would be a little parabola shape. Except it says we don't need values unless they're less than -1. So -1, -2, -3, is everybody okay that those are getting less than -1, going down from -1? If I put them in to get a couple ordered pairs, unfortunately, see, -1 squared would be 1, that would be 3, -2 squared would be 4, times 3 is 12. I think we're already off the graph paper. Open or closed circle at -1, 3? Everybody understands why? Because it's a less than, not an or equal to right there. So at -1, 3, they had an open circle, and then at -2, 12, it was going up this way and off the top of the graph, and that's a horrible picture, but we're going with it. Okay, -1, horizontal line, easiest kind ever, our favorite. This one goes from -1, -1 to -1, 4. Either of those open? Which one? The one at -1, 4 is, or 4, -1. I said that totally backwards. -1, -1. I said that one right. But then it should have been 4, -1 was the open circle. All right. This is values of 4 and greater. What kind of circle at 4? Closed circle. If I put a 4 in here, I get 4 minus 5 is -1, cubed is -1, plus 2 is 1. So at 4, 1, I have a solid circle. If I put in a 5, I get out a 2. If I put in a 6, I get out a 3. I'm just doing these fast. If I put in a 7, I get out a 10. Now, how should I actually draw that? What shape is this? It's a cubic, right? That's been shifted to the right 5, so it actually is like concave down, and then it's concave up. I missed totally those two dots. The half-power big dot theorem is really, really, really big. All right. Can we do, is there one left we didn't do yesterday? Okay, let's try 34 together for a little more practice. Anybody want to come up and do the first part? Got this one, Miranda? Do the first little piece. Yeah, I'll turn my tablet off. That might help. Okay, how'd she do, guys? Yes or no? Starting at x equals -5, the y value is 4, and it says for values less than -5, so that'd be -6, -7. Good job. Anybody want to try the next chunk? Go ahead, Sarah. Try it on your paper, guys. If I were you, I'd write a little chart. You don't have to, but you can. It says -2, -1, 0, 1, 2, right? Those would be all the values from -2. Uh-oh. I did the same thing. If you put in a -2 and cube it, what do you get out, guys? -8. Yep. Should have gone. There you go. The first one should have been -2, -8. Yep. Put the pen down. Pick up the eraser. And then just erase it. The one you wanted to erase. Do good. Yep. Okay, wait a minute. That's the one that was wrong. That one should have been at -2, -8, so go down 8 for that one. That's okay. There we go. Solid or open circles on the ends, guys?
Solid.
Solid. Beautiful. Yeah. All right. Anybody think they got the last one? It's kind of hard.
That's a pretty good looking line right there.
I think you all did marvelous.
She drew a really good line.
Cubic curve, you mean?
Same difference. My second grade brain.
Whoa. Till I got a hold of it. I was just going to make dots there. All right. This is a hot mess. If I put in values 3 or greater, like 3, 4, 5, do any of those come out nice? Put in a 3, I get square root of 6. 4, I get square root of 7. 5, I get square root of 8. 6 is nice, because 6 is square root of 9, which is 3. Can I get an approximation for square root of 6? Is that right? 2.48? Nobody's got the calculator up. Yeah, 2.48, 2.49. Okay, so we're supposed to have an open circle. I would never give you this problem because there's no way to tell if you accurately did it. Go over 3 and up 2.5 and put some kind of giant open circle. What shape is a square root graph? It looks like this, right? But if we're only looking at this little chunk, it's pretty hard to tell that it's curving. By 6, it's all the way up to 3. The next one that would come out nice would be what, like 13? Would it be at 4? Because the square root of 16 would be 4. Yeah, it's supposed to be a curve, but it's really hard. I wouldn't give you a square root like that. It's too hard to tell what's going on. Any more questions on those? Did anybody work on those last night and have trouble? Okay. We need to talk about worksheet 8B then. We've actually done problems like number 1 already in the quadratic chapter. Remember, we took this vertex form of a parabola and we put in the vertex. Can anybody tell where that vertex is supposed to be? -3, 0? Is that what you're going with? Okay, and where did we put those numbers in? The H and the K. Which then we made this plus, right? But then we still have to figure out this stretch. We have to find the A value. Remember doing this? It was even on the quiz for the summative at the end of the chapter for quadratics. We need to pick another point. This dot paper stinks. We could think some of these are right on ordered pairs and they might not work out so nice. Does somebody want to pick one that they think is on one, or do you want to just use the one they gave us down there? I don't care.
There's one, it's in the second point in the first quadrant.
This one looks like it's right on?
Yeah, 5.
2, 5. Okay. I don't know how this is going to work out. If we put in a 5 and we put in a 2, what do we get? Yes, this is 2 plus 3 is 5, squared is 25. We have to divide both sides by what? Be careful. By 25 to get the A by itself. And we got 1/5. We could, yeah, it's right. We could have put this one in and we would have gotten the same thing out. All right, so the answer they're looking for is 1/5 x plus 3 quantity squared. You could put a plus 0 on the end, but you don't need it, right? That, I hope, sounds familiar because we did that in the quadratic unit. We're doing the same thing now, but with different shapes. What is the parent function for number 2? I wouldn't even use a parent function. Number 2 is just a line. So I'm thinking we need, what?
Y equals mx plus b.
A slope and an intercept. Which one do you want to tell me? The slope? Be careful, be careful, be careful. Because this dot is not in the, it's in the middle of nowhere, right? So if we go here, how's that look? Do those look like they're right on the dots?
Yeah.
Yeah, so what would that be? What did you decide, Emerald? Down 5 and 2 to the right. Does that seem like an okay slope, guys? Do it several times, and if it seems to be okay, then you're probably right. Otherwise, if you do it once and then you do it again and it's not landed on the right dot, then you probably need to try again. I don't like this dot paper. I'm going to try to find a better worksheet next year. B. What's the B stand for? The y-intercept. I don't think it's 5 though, is it? It's 6.
It's because I got confused. I'm just coming up with excuses.
Yeah, you're all good. Negative 5 halves x plus 6. All right, those are the easy ones. Yes, the lines. Even Algebra 1 students should be able to get those lines right. Okay. Number 3 is a parent graph of?
Y equals absolute value of x.
Yes. Now, we need to decide where all this shifty, crazy business is going to go. It is negative, so it's going to have a negative out here.
And it was shifted to the right.
But the absolute value graph normally does this, yes? So a lot of teachers call this a vertex. I honestly don't know if it's actually called a vertex, but that point right there, okay, is now way up here, right? So what did it do? Right? 5 and up 4, Jared says. Are we agreeing? Okay, does anybody know how we put that in?
X minus 5 and plus 4 outside that.
Perfect. It's just like vertex form of a parabola. It's ax minus h plus k, all right? Now, it is going to have a negative out there, but I think it also has a stretch. So let me erase this picture so I have a little room to work down here. Can you find me another ordered pair? Let's use that guy right there. What's that one?
4 and 1.
Yep, we could use that one. 4 and 1 is that one over there. Perfect. If I put in the y is 1, right? The a we don't know. The x is 4. We said this was minus 5 and this was plus 4 from over here.
Can we just find the slope?
Yes. It's going to be 1 equals, this is negative 1, but the absolute value makes it 1. So we have 1a plus 4, which means a is negative 3. Miranda asks, can we just find the slope? The slope of this branch is positive 3, and the slope of this branch is negative 3. But yes, you could have determined that the slope was 3, and then you would have had to realize that the negative meant it was opening down. All right, so final answer, let me do that in blue so that you can tell what it says. Y, oh man, there's no room there. Y equals negative 3, absolute value of x minus 5 plus 4. Did I get it right?
Yep.
Okay. What is the parent function on number 4? 4 is this one right here.
Y equals x.
Y equals x cubed. Okay, and what does that graph normally look like though? Goes through 0, 0, 1, 1, 2, 8, like this, yes? Is this one doing that same thing? Maybe.
Close.
It's definitely been shifted. What we have to look, and I didn't draw mine well, but this point where it changed kind of an inflection point thing, how it was going that way and then it swung around and was going that way, that's the point that shifted to here, yes? Do you see what I'm talking about? That's the point where it changes concavity. So it went 4 right, is that what you said? And 2 down? Okay, does anybody know where those would go in on this cubic though?
Y equals minus 4
Good call. Okay. We still have to find if there's a stretch. You guys are going with there's not, because it went over 1 and up 1 originally, and it's still going over 1 and up 1 from it. I don't think there is a stretch. If I put in this point right here, which is 6, 6, I get 6 equals A times 6 minus 4 cubed minus 2. Is that 0.66?
Yeah.
Okay. This would be 2 cubed is 8. I would add 2 over here. And I divide and get 1. That was a waste of time, right? You told me you were right. I was just proving it to you. So this is our equation for number 4. All right, you ready to try one on your own? What shape is number 5? Anybody know the parent function? Yes. So, guys, the form is the same. The stretch is multiplied out front. Any shift left or right is inside, and any shift up or down is outside. The square root function, though, normally goes through what points? 0, 0, 1, 1, 4, 4, 2, because it's square root, yep. So what this corner right here, this starting point kind of thing, is way over here. So think about that for a second. How much left, how much down, put those numbers in, try to find A.
8 left.
After you put in your H and K, then you need to find another point to put in to find A. Is that -7, -2, or -3, guys? Okay. So H is going to be left 8. K is going to be down 6. And then I'm going to use this for an X and a Y still. -7 plus 8 is 1. Square root of 1 is 1. 1 times A is A. So we have -2 equals A minus 6.
Couldn't you just done like the point? That point used to be 1, 1.
Yes, this point right here used to go up 1 and over 1, and it went up 4 and over 1. So that's our check. So final answer for what number are we even on? 5 is Y equals 4 square roots of X plus 8 minus 6. Last one, parent function for number 6. Oh, I didn't put any absolute values in here to make life miserable. No. I mean, no, like, weird absolute values on the function. They're all the parent functions that you have on that sheet. Cube root? Okay. But a cube root normally goes like, it is a cube root, but I think it's been flipped. I think when we plug in our values, we'll find A is negative. Okay? So normally this inflection-y kind of point here was at 0, 0. So it went what?
Down 4, down 1, 1.
Cubed root. Man, I can't write. Okay, it's a cubed root. What did we say? -1, -4? And then maybe, is that one look like -2, -2? We can plug in a minute. These are our H and K though. So can anybody plug in the H and K for me? I didn't write it down. What would it look like? X plus 1, and on the outside would be a -4. Alright, I chose -2, -2 as another point, so I'm going to put them in. I like that point because I can't mess them up and get them backwards, right? Now, all day, every class has answered this question wrong. Let's see if we can get it right. Can I take a cubed root of -1? Cube roots. Yes, right? Not a square root, but a cube root I can. Because -1 times -1 times -1 is -1. So this simplifies to -1, and the cubed root of -1 is -1. So I have a -1a minus 4 equals -2. What do you get if you solve that? Add 4 is 2. Did I do something wrong?
No, that's right. That's right.
Okay. Does it make sense? Instead of going 1 and 1, it went 2?
Yeah.
It's stretched vertically, right? Seems weird because it's going sideways, but it is stretched vertically. All right, so final answer for number 6. Anybody have it?
Y equals -2 times the cube root of x plus 1 equals quantity minus 4.
Nicely done, guys. Now, if you were taking a test or quiz, could you type that in your calculator and check that it looked exactly like that? Look at the table, make sure it was going through the same ordered pairs? It would be totally able to check that you did that right. Okay. I would like us to look at the back of worksheet 10. Because there's some that look confusing to somebody. Which ones have we not talked about one like? You think those are easy? Okay. But you got to find the stretch too. And sometimes people don't know how to write them. You're right, Kate. I think they're pretty easy because Kate's talking about is it 21? Yes? Number 21, I think, yes, is, what's that called? Does anybody remember on the parent function sheet? Yeah, it's called a reciprocal function, which is 1 over x. Normally that graph would go through 1, 1. At 2 it would be 1/2. At 1/2 it would be 2, so it would look like this, and it would have a branch down here. The trick is the normal asymptotes are x equals 0 and y equals 0. And no, I didn't label those backwards, right? X equals 0 is a vertical line. It's the y-axis, but it's x equals 0. All right. The asymptotes intersected here at 0, 0. Where are these intersecting on this picture? Left 5 and up 3? Or -5, 3? Okay. We got to figure out how to put that in here, though. Anybody know? That would be -h, right? Where's the k going to go? Yes. So it goes just on the back here, which is +3. Now, to find a stretch, and there is a stretch, you would multiply it, right? Now, if I write it like that, that's okay. But where else could I write at the A? Yeah, because it's A over 1, right? So it just multiplies onto the top. So I could also write this. There will not be one of these on a quiz, okay? But we're this far. We need to figure out the A. Can you find an ordered pair? Any ordered pair that's actually on the graph, not on an asymptote? I got 12 different answers. Is this one -6, +1? Or this one is -4, 5? Either one should work. Okay. All right. I'm going to go back and plug it in here. Which one do you want me to use? Doesn't matter. If I use -6, 1, I get this, which is A over -1 plus 3. Or 1 equals -A plus 3, which would be A equals 2. Did somebody try it with the other point and get A equals 2? No? Did you? You still got A equals 2? Okay. That's okay. She's just working away on her homework. All right, guys, so that means the final answer is we get to take that A out and put in a 2. How do I know that it's not negative? It's still going the same directions, right? It's like it was in quadrant 1 and 3 and it just shifted over. It's now in different quadrants, but it's still in the right position. It hasn't flipped upside down or anything. All right. I'm going to stop the recording because that's all I really have for today, but we can go ahead and finish up some more of these together if you want.